Okay, so instead of diving into the new content, we're going to make sure that the stuff we learned the week before fall break is, still fresh in your mind. So these 12 questions covers the quadrilaterals from the week before fall break. I'm going to make sure that you are aware of how to set it up before I turn you loose to work on it, okay? Because I know that you've slept since fall break. So looking at number 1, what shape does it look like? Looks like a parallelogram. And then it gives us info on the angles. Notice the angles are related to each other in what position? Are they opposite or side by side, which we call consecutive? How are the angles positioned to each other, the ones they give me? They're opposite. B and D are opposite. Do you remember the property on opposite angles of a parallelogram? They're congruent. And this is where that summary sheet is going to help you. If you look at your summary sheet, the summary sheet will tell you that opposite angles are congruent. So angle B is equal to angle C, and that's going to be how you set it up. Okay? Now, I don't want you solving it right now. Let's move on. Let's make sure you know how to set up each one of them, and then I'll turn you loose. Look at the next question. Once again, we have a parallelogram with angle information, but what do you notice about these angles? They're different, right? They're no longer opposite. They're now on the same edge. Remember we talked about this? If I trace this edge of the parallelogram, those angles are on the same edge. So are they congruent, or do they do something else? They're supplementary. Do you remember what that means? They add to equal 180. So angle P plus angle Q adds to equal 180. All right, go to the next question. It says, if XV is 27 minus 2x, so 27 minus 2x, and V to Z is 3x plus 2, find the length of VZ and XZ. What info are they giving me? Is it angles or length? They're giving me lengths. And then what part of the shape are these lengths? Are they edges, the sides, or the diagonals? Are these what I just labeled, are those the sides or the diagonals? Those are the diagonals. Look at your property for diagonals on a parallelogram. Look at your summary sheet. Go to the parallelogram box. Huh? They bisect each other. That means they're what? What does bisect means? They cut in half, right? They equal half plus half equals the whole, or just the half equals the half, right? So this X to V has to equal V to Z. They're equal. All right, look at the next one. We have a rectangle. And are they giving me info on angles or length? Angles. They're saying that this angle, 2x plus 17, is right here. And then they're saying 11x minus 10 is up here. What do you notice about those angles? They They are congruent. Why? Do you remember the vocab word to describe what they are? It's 3 words. Alternate interior angles. Very good. So those angles are congruent. I'm not going to write that out because the angles lengthy, but they're congruent. So that's how you're going to approach that problem. All right. E. They give me JL, and they say it's 5x plus 1, but they're giving me the whole thing, right? So I'm just going to make it really dark. I'm going to draw an arrow to it, and I'm going to write 5x plus 1 to let me know that the entire thing is 5x plus 1. Then they give me MK. Once again, that's the whole thing. So I'm going to draw an arrow, make it dark, and I'm going to write 8x minus 32. So those are what part of the shape? Sides or diagonals? Those are the diagonals. What do we know about the diagonals of a rectangle? Go to your summary sheet. Rectangle. What do you know about the diagonals? They're congruent. So these have to be equal. JL has to equal MK. All right, look at the next one. We have RV is x plus 6. X plus 6. US is 5x minus 9. Oh, US, that's the whole thing, right? The whole thing is 5x minus 9. And then they tell me RS is 11. They asked me to find VT and ST. They want this and this. There's a lot of information going on here. What shape do we have? We have a rectangle. Okay. What do you know about the diagonals of a rectangle? They're congruent. Okay, so notice that 5x minus 9 is the entire diagonal. Do you see that? Is x plus 6 the entire diagonal? No. It's only r to v, right? Okay, so if r to v is x plus 6, then what is v to t? It's also x plus 6. Now you know that the entire length of S to U is 5x minus 9. And then what's the entire length of R to T? Well, it is going to be equal to it, yeah. You've got x plus 6, how many of them? 2 of them. And that has to equal the 5x minus 9. You got the 2 parts, has to equal the whole. Do you see that? Part plus part equals whole. And the 2 parts are equal. X plus 6, x plus 6. Does that make sense? So we need to solve this. I'm going to help you with this one because there's a whole other step involved. Let's solve this. What's x plus x? 6 plus 6. Now we're ready to start moving things to the other sides. I'm going to move 2x underneath the 5x. Then I'm going to move the minus 9 underneath the 12. What do I get x to be? length of x. It wants you to go back and plug it in to get the length of vt, but then they also want st. We don't have an expression for st. So that's where there's a little bit more work involved here. There's no expression for st over here. What shape is embedded in a rectangle if the diagonal is drawn? What shape do you see? A right triangle. I'm going to come over here and trace it, or draw it again. We have a right triangle. They tell us that this is 11. We know x is 7, right? Plug 7 in here. What's 7 plus 6? 7 plus 6. 13. And then you'd have another 13. So what's the length of that whole side? 26. And then this is the one we don't know. What's going to come into play here? Pythagorean theorem. This is going to involve the Pythagorean theorem. So this is your hypotenuse. We don't know this one side, so we're going to call it a squared plus 11 squared equals 26 squared. And we've got to solve this. And I'm going to leave it at that for you to solve. Write that down and then go to the back and let's do the ones on the back together. Okay, going to the back. Let's look at these. The first 4 questions are referring to rhombi. From here, from here to here is referring to rhombi. And then the last 2 questions is referring to squares. So look at your properties for rhombi. It says, find the measure of these angles. Right? We have diagonals drawn. Notice what it says in the properties for your rhombi. What's it say? Diagonals are perpendicular. So this is a right angle right here. So that's a right triangle. What else does it say about the diagonals? They bisect the opposite angles. What else does it say? That's it? Okay. Hold on 1 second. Okay, sorry, I had to answer that email. All right, So look right here. We have a triangle. They give us info on two angles, and you just read the property on your summary sheet that the diagonals are perpendicular, which means there's a secret angle given to you right here of what measure? 90 degrees. Do you remember how many degrees the angles of every triangle add up to? The sum of the angles of every triangle is what?
360.
It's not 360.
Triangles add up to, the angles of triangles add to equal, you said it a second ago, but yeah. Y'all don't remember that?
No, not really.
Okay, that's like the biggest takeaway of the entire course.
I'm gonna have to rewatch this video like 50 times.
The angles of every triangle add up to equal 180 degrees. You might want to write that at the top of your paper. The angles of every triangle add to equal 180 degrees. The angles of quadrilaterals adds to 360. And that's because if you draw one diagonal, you now have two triangles. Two 180s is 360. So we have these three angles and the 90, they have to add up to equal what? That's going to be your approach here. Okay? That's going to be your approach there. You're going to add them to equal 180. All right, look at H. We have another rhombus. We're talking about angles. Will you read the property that discusses angles under the rhombus picture? The property that talks about angles. Diagonals bisect opposite angles. This diagonal has been drawn, so this entire angle has been what? Bisected. What does that mean? Cut in half. So that means that this is equal to this. And that's going to be your approach. They're equal. Okay? Alright, look at the next one. It says ZX is 74. That's the whole thing. So we'll draw an arrow, make it bold. Then it says WY is 48. That's the whole thing here. So I'm going to make it bold, draw an arrow, and write that that's 48. Find VX and ZW. What do you notice about the properties of diagonals in your, what's it say? It says they do what? They're perpendicular. So what shape do we have here? We have a rhombi with the diagonals drawn, and when the diagonals are drawn, we now have right triangles. We have right triangles here. Now, the diagonals also include the properties of parallelograms. So the diagonals have been cut in half. So what's half of 74?
37. Right.
Yes. So this would be 37 and this would be 37. What's half of 48?
24.
So this is 24 and this is 24. Now this is getting really crowded, so I'm going to redraw that triangle. So this was 24, this was 37, and this is one of the things we have to find. What are we going to use here? You're going to use the Pythagorean theorem here. This is the one you're trying to find. So we have 24 squared plus 37 squared equals c squared. Now, we already found Vx because we cut 47 in half. So we've already found Vx. Now you just have to find Zw. All right, look at the next one. It tells us the perimeter is 72, and then it says RV is 16. This is a rhombus. What do you know about the edges of a rhombus? Look at the properties. What does it say about the sides of a rhombus?
They're congruent.
4 congruent sides. Y'all, a rhombus is a square that's just been pushed. So all 4 sides are congruent. So if we know that the perimeter is 72 and all 4 sides are equal, do I have enough info to state the length of all 4 sides? How do I get it? Yeah, 72 divided by 4 is what? What's 72 divided by 4?
You said 72, right?
72 divided by 4
Yeah, it's 18.
is 18. So then all of these are 18. And once again, you have a Pythagorean theorem. This is the goal, UV. So once again, you have a Pythagorean theorem. You've got 16 squared plus b squared equals 18 squared. The last two should be the easiest ones because they involve squares. Squares are the properties of parallelograms, rhombus, all put together. This says find the measure of angle DBC and AEB. AEB is right here. Look at the properties of squares. It says what? So look at the property of rhombi. What do you notice about the diagonals of a rhombus? What does it say they do? They bisect at opposite angles, but they intersect at what? 90 degrees. So one of the angles is 90 that it's asking for. The other angle, this is a 90-degree corner, and this diagonal is drawn. If you bisect 90, how many degrees is that? If you cut 90 in half, what do you get?
45.
So then this is 45 degrees right here. There's no math to really do here because it's a square. Squares are the same no matter what they look like. The only thing that changes is the length of the edges and the length of the diagonals. The angles are the same every time you have a square. 90 corners, 90 in the middle, and 45 individual corner angles. All right, look at this one. PR is 14. That's the whole thing. It asks for ST and QR. You're going to have to do the Pythagorean theorem again. Right here. I will be happy to go over that one at the beginning of class tomorrow.